Okay, so hi, my name is Dana. I'm going to be a junior next year, and I'm really interested in robotics. And my group or team was interested in space exploration. So we tried to merge the two ideas in the application that we created called MarsNet RL. It is an AI system that helps satellites autonomously navigate and avoid collisions with space debris, specifically in the Mars environment.
Cool.
This is it?
Uh-oh.
My button's not working.
Um,
I
is it
can't
a
go.
down? Is it a down arrow key for us?
Down arrow?
No arrow's working. Sorry.
It's fine. Just press the oh there.
Is it
Still
the
there's nothing lagging.
Okay. So, as you know, satellites are used for imaging, mapping, and research, specifically in space. And a really popular topic or of interest in space are the planets. A very popular planet that people are interested in is Mars because of how close it is to Earth and also its potential to be habitable. So to research Mars, there's going to be more satellites that are going to be sent to orbit the planet, and that will create more traffic and a higher potential for collisions to occur. As a result, scientists should have a goal to decrease these collisions and manage traffic by allowing satellites to become autonomous. So my team was really interested in this problem because of the 24-minute communication delay between Earth and Mars on the highest end. And this communication delay makes it hard for direct communication to occur and means that satellites should or must be autonomous to avoid these collisions. When I talk about the collisions, I mean with space debris, and a very populous form of the space debris are inactive spacecrafts that are still orbiting Mars and cannot get out of the orbits. In addition, the satellites that are being sent, a few of them may cross different altitudes, which means that they're probably going to come in contact with other satellites that have already been sent. So in terms of real world occurrences, currently there have not been any major collisions because of how few satellites have been already launched. But as I said before, more satellites are going to be launched because of the interest in research. In terms of the direct communication, a lot of the orbiters currently use a communication network that NASA has already created, DSN. However, this network can only receive data from 4 orbiters at a time and can only give back information to one at a time, which makes direct communication difficult. Another factor that makes this direct communication difficult is that Mars turns or rotates, and because of that, Mars will be in the way of direct communication for about half of a Martian day. And as a result, then satellites need to be autonomous. When just going back to the space debris is stuck in the orbit because the atmosphere doesn't pull it into the planet like it does on Earth. And not only is a collision bad because you lose money or you lose that satellite, but because when a satellite breaks into multiple pieces, there becomes more space debris in the orbit that's never gonna get out of the orbit, and that means that there's more for currently working satellites to avoid. Because of all these problems, my team thought of a solution, and that was to create a demo version of an AI system that simulates this Mars environment and has an AI system that helps the satellites autonomously navigate. So my system uses reinforcement learning and a point system. So the system gains points for avoiding collisions and loses them or is heavily penalized when collisions occur. There are multiple satellites, so there are multiple instances that the system can learn from, and there's obviously space debris that the satellite should avoid. So let me show you my app, which is right here.
Cool.
Okay.
Make it full screen if you will. You have to do that, right? F11. Press F11. Make it full screen, right?
F11.
Function key F11 if you're on your laptop.
Yeah, it's not.
Yeah.
Are you on a laptop?
Yes, I have F11, but it's not doing anything.
If you see that key set that says FN next to the Windows key. Okay, one thing. Is pressing F11 just making your screen a little brighter, a little less bright?
Do you want it brighter?
No, it's not the screen brightness. Okay. There must be a key called FN written on it next to right at the bottom. Okay. You know what?
Yeah.
It's fine for now. Let's just keep going. Again, remember to use the function keys, right? There's a key called FN. If you have to
Yeah.
hold that and then press F11. Okay. I missed. Cool. Just please go ahead. Another happens
Right.
time.
So this is the landing page for the app. It has obviously the name and then a little description of what it does, autonomous satellite. There is a little toggle for aesthetics if you want. On the bottom, it shows the three main components of the simulation. So there's the telemetry, or just the data that Earth would receive about the satellite. So how fast the satellites are going, or if they're actually evading the space debris. There's a chat box. And then there's the AI system that is predicting which areas have potential for collisions and then moves the satellites away. So this is the button to get to the simulation. I'll start it.
Cool.
And then, so this is what it looks like. There's Earth, there's Mars. And then if I scroll in, there are the four main orbitals that satellites are probably going to be launched to. And if I go even closer,
Okay.
and if I go closer, you can see there are labels, and that those are labels of the satellites. So it has the number of the satellite and also the status. So if it's green and it says okay, then it means that it's not actively avoiding anything. But if it's yellow, as you can see, and this is evade, then it knows that it's close to a piece of space debris and will move accordingly. So if you can see this one, it's gonna like move. I don't know if you can see it, but like they make like really small adjustments, or they try to like move side to side to get away from this space debris. Also, they're not all just following the line, they're on like different heights and everything. So you can see that working. And on the side, you can see all of the points that the system has ever had, and all of the collisions and hazards it's had from the beginning when there's training. There's a little sidebar for the satellites, so I can move it and change the amount of satellites they are and their positions. This helps the system learn. There's a training mode, I can animate the satellites. On the top, there are just some percentages, so like fuel, how much fuel the satellite has. Obviously, the fuel in my system doesn't run out, but the satellites do move at different speeds, so that's worth noting. Yeah, and on the bottom, there is a little description, as well as it shows the amount of satellites that are in the simulation, how many are currently evading. There's the chat box, as I said before. And finally, there's a little training log, shows the status of each satellite. So you can see if there's been a collision, or if the satellite is not avoiding, or if it is avoiding, it shows like action 1, 0, 2, whatever. And that just shows, did the satellite choose to move inwards to avoid, or up, or down, or anything like that. And that's it.
Okay, that's really cool. Once again, like each of these satellites, how much like knowledge do they have? Does that make sense? Like are they, because again, like if they just have if they have knowledge about every other position, every other object's position, or is it just they have knowledge of their own position as well as some sensors to detect what's around them?
Yeah, I think they know their own position, and then they know if anything comes like in like an 800-meter range, then it will move.
No, it'll detect it automatically. Okay, cool. Okay. Cool. Okay, so they're going around avoiding each other, like it's obstacle avoidance, right? Got it. Cool. All right. So reinforcement learning is going on, right? So, are you using a specific reinforcement learning model, or like is it just like a basic reward system?
I think it's just a basic system.
Right? Okay. In your own words, how would you what do you would define reinforcement learning as? Can you like explain reinforcement learning to me?
I would say that you give the AI system multiple different situations, and then it keeps you like give different or new situations to it, and then it makes an action, and then it either gains points or loses them, and it starts learning after multiple different situations. Oh, I tried this before, that didn't work, and then it like knows when it's given like new situations which actions were good and which actions are bad.
Cool. Okay. Exactly right. It's a carrot and stick method, but like applied to robots and stuff, right? Because like it is used in robotics, is used in like stuff like this, right? Where like there's no like correct answer per se. There's no like data to kind of go off, right? So all you have to we just know what's good and we know what's bad, right? So we just say like try something out. If you're doing well, then we'll give you a reward. If you're doing badly, then we'll punish you, right? Right. So again, it's just a carrot and stick method. Okay, so I really like the simulation that you made over here, right? It's like one thing like I feel like okay, so right now the only data you're using is like the sat. It's completely autonomous, right? Like because you're looking at the satellite's position as well as the 800-meter radius around it. Is that correct?
Yeah.
Right. Okay. So how would you like make this model a bit more realistic in the future?
Um. So I would say that space debris probably doesn't stay in one place. So I would
Yeah,
probably have it
definitely.
do what?
Those okay. Yeah, definitely. I was agreeing with you.
Yeah, so it needs to be like moving in random directions at different speeds. So that would be more realistic. Also, the orbitals probably wouldn't all be horizontal. So I would have to make more orbitals going in different directions, maybe. Um,
Yes, and one more thing, like something that can help you out as well here, right? But that can be a bit annoying as well. Is that remember Earth is also communicating with these satellites, right?
mhm.
So, but as you said before, right? Like sometimes there is a 21-minute delay as well as this like there is a bit of like what do you call it? Like some certain times Mars is blocking the signals, right? So they can't communicate. But Earth can still provide valuable information, right? Does that make sense? Right? So
Okay.
these satellites need as much information as they can have, right? So using physics and like last known equations, like Earth quite knows quite a bit as well, right? So we can simulate that as well, right? So everything that is visible to Earth at this point, like from there, will be tracked with a 21-minute delay, right? And that can also be used by these by the training algorithm somehow, right? Because if it has like a rough map of like, okay, I know like roughly what 20 minutes ago what the map was like, then like it can kind of predict what can happen as well, right? So that can be
Okay.
a data point. Right now, it's only looking at stuff around it.